Alright, so here we're going to do a quick combustion problem. And we're told that we have 10 moles of propane, C3H8, undergoing combustion with 40% excess air. If 3 moles of C3H8 are found in the product gas, calculate the moles of the remaining components in the stack gas. Alright, so first off, let's write our reaction for the combustion. So we're going to be adding oxygen, and the products are going to be CO2 and H2O. But we need to balance this, of course. So we are going to put a 3 here, a 4 here, and a 5 here. Alright? And we know that we're starting with 10 moles of C3H8. So let's find out the amount of air that is coming in. And we can use a relationship from this equation. For every 1 mole of propane, there are 5 moles of oxygen. Okay? And in air, 1 mole of air has 0.21 moles of oxygen. And because there's 40% excess, we're going to take the amount of air we have and multiply that by 1.4. And that'll give us the amount of air that is coming in. And we get that to be 333.33 moles of air coming into our system. So let's draw our little combustion chamber and the stream that's coming in. We have 333.33 moles of air. And if we break that down into its components, we have 70 moles of O2 and 263 moles of N2. And let's not forget that we also have our 10 moles of propane coming in. Okay, and what do we have coming out? They told us that we have 3 moles of C3H8 left over. Okay, and we also know that the nitrogen is not changing, it's not reacting with anything. So that's going to be 263. I'll add the extra 0.33 moles of N2. Alright, and because there's 3 moles of propane left over, that means that 7 moles of propane must have reacted. And what are the products? We can find that out from our balanced equation right here. So for every 1 mole of propane, we have 3 moles of carbon dioxide and 4 moles of H2O produced. So going back here, if we have 7 moles consumed, that means we'll have 21 moles of CO2 produced and 28 moles of H2O produced. Okay, so the only thing that's left to look at is the oxygen. So if 7 moles of propane reacted and 5 moles of oxygen are needed for every 1 mole, that means that 35 moles of O2 were consumed. And out of 70, that means that 45 moles of O2 will be left over. Alright, so we have found all the components in moles of our stack gas, so we have successfully solved this problem. Thanks for watching, and if you found this helpful, tune in to some other videos.